Hello, thank you for coming. I hope you will enjoy the talk today. So I will talk about the React renderer for the smart home. My name is Alexey Zaslavsky, and I work in a small outsourcing company called WebbyLab here in Kyiv. Today I will show you something special because something that you've probably never seen. You'll see how you can control your application, JavaScript, using React. You can control a few real devices. So I believe you're used to creating DOM elements, writing code for the browser, or if you're a native developer, you write your app in React Native for mobile phones, but this is something different. So for example, I have a small teaser here for you. I hope it works. So I can turn on my lamps, smart lamps remotely, and I can actually make a small disco app. So this is a small teaser, and I'll show you a few code examples. So how you can write such application. It should be pretty easy. If you are used to React, it shouldn't be complicated for you. So, but I'll start a bit from far behind because actually, React has evolved a lot, and everything started from React Fiber, I believe. So, React Fiber is the React core algorithm reimplementation, which has landed in React version 16. And React Fiber actually has a lot of cool features like priorities and scheduling. So, in the future, you'll have a lot of interesting stuff. So if you're writing your app and a user needs to type something into an input, and there is this off-screen element, your priorities of the rendering should be different. And this is what React, I believe, should handle in the future. There are also a few interesting features like error boundaries. So this is basically component did catch method, try catch for your components. In the future, we should also see the asynchronous rendering, which should be important for very big apps. So your rendering can be stopped at some point. Some other work can be done, and it will be resumed. But one of the less known features is the API for custom renderers. So if you're used to React, there are a few official renderers from Facebook. Actually, the first one is the React DOM for the browser, React Native for the mobile phones, and React 360 degrees for three-dimensional scenes. So this is basically a renderer for WebVR. One of the less known renderers, this is the community project, is called React Blast. It allows you to write applications for a terminal. It's pretty easy to build applications like this. It looks pretty complicated if you use just like N courses. If you wrote some applications for the console, it's pretty hard to do. But with React Blast, it's simply a wrapper for the Blast library. It's pretty easy. So you write everything as you did before, except for the view part here. So in the render method, you'll have different components, like the box component, for example. This is React Blast specific part. And also you'll need to learn a bit of the view specific things like box, text, etc. And the styling is different. But your other logic of your app, it's almost the same as you write the logic in React or Redux, all the stack that you use. So there is one question that I had a while ago. Well, it's pretty easy to write user interfaces using React, but can you write something that is not actually a user interface? And a while ago, a new project has been released called React Hardware, and React Hardware is something different. It actually allows you to write your application for the Arduino, and well, basically it allows you to blink the LED. This is what Arduino is for, right? And then you throw it away, as everybody does. So you connect your Arduino to your computer, you connect some LED element there to the pins, and then you write your app It should be like this. Then you write your app. This is some kind of regular component, just like with React for DOM. Everything else is the same except for the render method. And the render method is a bit different because you don't render a user interface. You actually pass some value to a pin. This is something different. And then in the render, you say, OK, I want to render this. I want to send signals to the board, to the Arduino board. And React Hardware is a cool project, but I thought, OK, so if we can write something for Arduino, we can write something from a smart home, because at the time I bought a smart home kit and I was looking at the APIs that I could use to program it without using some official apps. So if you think about the renderer, the idea of the renderer is pretty simple. So you can render user interfaces, and not only user interfaces, in different environments using almost the same tools. So if you use like React Dev tools, Redux Dev tools, you can use them here. You can have declarative component-based UI, and not only UI, of course. Declarative, so you can compose your components just like you do in regular React. And, learn once, use anywhere. This is the basic principle of React. You use almost the same tools, but you still need to learn a few specific parts of the specific platform that you use. If you're used to React Native, you know that, OK, you wrote for the web, you become a React Native developer. It's almost the same, but you still have to know to learn how to use the styling. There are platform-specific parts. So this is something new that you need to learn. I've been thinking about the life cycle of the user interfaces, because and the user interfaces and the devices, and they actually have a lot in common. So the first phase, I'd call it, in the initial render, is something that happens in the beginning when you start working. When you work with the DOM, you have a few methods that are called when even React initializes the element, like the div. For a device, you have something similar. So if you have some kind of device, if it's Arduino board or a smart home device, you still have to connect to it. Then you should add some listeners to monitor specific parameters. And the main part of the app is the work loop. So in the work loop, you actually change parameters. So for the DOM, you might change the text content, the styling, etc. For device, you change different things. You change the power state, brightness, and any other parameters that your device actually supports. And at the end, the unmount process, process when you call remove child for the DOM, and you could have different methods to disconnect from the device and remove the listeners that you created at the beginning. OK, so if we think about what can be rendered with React, this is not only a user interface. This could be a tree, right? So the DOM is the tree. The components in React Native are a tree, are trees, right? And so it should be a tree, or even a virtual tree. And this tree should change over time. So it doesn't make sense to use React if your state doesn't change, if your view or your configuration doesn't change. OK, so the flow for a device is a lot simpler than for the DOM, for example, because what you have to do, a few steps. Just when you set state in your call set state in your React component, or you call force update, your big components, like if you write something like your user components, they are actually at the end rendered to, for example, in the DOM into divs, right? Or spans, or text, or view components in React Native. But actually, if you render something to a device, you could have some device component. It will have some props, right? And you need to calculate after the rendering, between the cycles, you need to calculate what's changed. So you calculate the difference in the props, and at the end, you just send the signal to the host environment, to the real device. OK, so please update this parameter or this parameter, what's changed. The flow is pretty simple. Okay, so the next part is the smart home appliances, and I'll actually talk about Xiaomi smart home. I believe this is the most popular smart home kit on the market nowadays. And well, actually, for first we'll need to define what a smart device is. So, well, you have like lamps, you have different devices, but they're not smart. What's the difference? And actually, pretty like this tweet, because it says, okay, in 1997, your light bulb emitted more heat than light, but in 2017, your light bulb is so cool that it can even DDoS GitHub without you even noticing it. So if you have a regular LED lamp, what you can do with it? You can just turn on and off, right? Not much. But if you have a smart light bulb, this is totally different. It should have some connectivity solution. It should have Wi-Fi or Bluetooth, for example. It could be remotely controlled using an application. And you can adjust different parameters. So for the lamp, for example, you can adjust brightness or color or the power state. So you could turn it on and off just as the regular lamp. So when I started looking into the smart home appliances, the first device I actually bought was the light bulb. I just interested in how I could actually control it. And the light bulb is I wouldn't say it's a simple device, but it's pretty simple to connect. It's pretty easy to connect to your network. So light bulb connects to the Wi-Fi, and what you have to do is just to initialize it. I mean, the specific Xiaomi light bulb, you need to initialize it. You need to give it your network parameters, and that's it. It's working. It's pretty simple. So after that, okay. And this is the official app. In the official application, you can actually change the different parameters here, like the color or the brightness, just by swiping. What you can do if you want to control your app programmatically. So there are actually a few protocols that can be used, and the first one that I found out was the protocol that is used to control the lamp through the Xiaomi Cloud. This is a proprietary protocol, no specification. Nobody actually knows what these devices send into China. But the second one, is the local network protocol, and it's also proprietary. I found out it's called MiHome. I don't know if it's official name or not, but the packages they found are called something MiHome, like PHP MiHome. And it's also proprietary, but it has been reverse engineered by a few developers, I think, and they released a few packages for different languages that you can use. Okay, so let's try to control the lamp. I have the first demo with just this one small lamp, and the first, okay, here it is. Actually, the first library that I found was a PHP, and it was called MiHome PHP. So, well, you don't want to control your lamp with PHP, right? But this is what I did. You need to control your lamp. You need something called a token, which is a string that you can obtain from the official app. This is also the problem of the Xiaomi smart home, that it's not entirely, it's not open source, right? You need to extract the backup from the official application from your Android or iOS. Then you need to take the backup and recover this string from it. And only if you have this string, you can send different commands. And this MiHome library allows you to send different commands to the lamp. Okay, so let's try to, I hope the IP address is right. Let's try to run it. If it's not right, it won't run. Okay, didn't answer anything. Just change the IP address, hope it will work. Okay, just need to turn it on, not off. Okay, so it's on. And now you can turn it off. You run just the same script, and you turn it off. That's pretty simple. So After that, I thought, okay, I can't actually use PHP in my renderer, right? So actually, this is what I did. The first version of the renderer was the React hardware project that I told you before. I just removed the Arduino part, and it spawned a PHP process, but please don't tell anyone, okay? So I went to the biggest garbage pile in the internet, the NPM, of course, and I found a similar package called MiHome. So this example is also pretty simple, but it's not a shell script, it's a JavaScript code. So what you need to do, you need to require the MiHome package. There is some configuration. Okay, this is the same token and the same IP address that we've seen before. You can set different parameters, just like before, the power, the brightness, the color for the lamp. Okay, so let's do it. Okay, I think this is demo 2-2, okay. And it works. Okay, let's change the color. Let's make it red, right? Yeah. Actually, you can pass something different. So the library understands any color that you can use in the web. So let's put yellow. Not really yellow, but okay, let it be yellow. Also, I set different brightness. Maybe if we set the brightness to 100%, this will be different. I hope so. Okay, that didn't work. Maybe you can put 100% there. Maybe 99. Yep. So 0 is also not a valid parameter for this. You can turn it off, but okay, it doesn't make sense if we set the color after the turning it off. Okay, so that's pretty simple. You can actually write your app like this, right? But this is, okay, this is not cool, but this is not React. Nobody would listen to you if you say, I just downloaded some library, right? And okay, wrote this code. This is not cool. But then I implemented a small renderer. Yeah, the first one used the PHP inside, but the next one used this MiHome. And the next example is a bit different. I have a note here for myself. Don't forget to open DevTools. Okay, I should. Where are my DevTools? Should be React DevTools, right? And we need to. This is the presentation. The next demo, demo free. Not sure why it's free. Okay, so here. You have the same code, whereas Visual Studio Code now. Actually, this is like 30 lines of code here. Part of them is, yeah, React Magic render your app. And this is the part of the imports. And the actual app here is not really bigger than the previous example. And here actually render to some kind of device. Okay, so I need to pass the address and the token as the previous examples. And I put different parameters here. And I could change the color, like in the previous example. Let me put red. Just need to relaunch the app. You will see red. Okay, let us put yellow here. Should be yellow. Okay, that bad yellow. Nope. So let's turn it off. Just relaunch it again. So, okay, I actually forgot about the DevTools. I open it, but one of the cool part here that you can use React DevTools for free. So you can observe your app just like you do in the web or React Native, for example. But yeah, it's not quite interesting because we don't have, we just make a variable here. We don't have state, right? We can't change it through DevTools. But we can see the parameters and the props that are actually passed to this device, right? Okay, so this is quite interesting. You can control your lamp, but that's not really useful like if you had a lot of other devices. And I went further and I bought different sensors. So, but for example, like this, if you hope you can see. So I have a button here, it's wireless, but it's not pretty simple to connect your button to Wi-Fi. It won't last 5 minutes if you, or Bluetooth, for example. So Xiaomi and I think other vendors, they have special devices. I think I have it here. Just one here is plugged into the network, and I have other one. This one is called the multifunctional gateway. And the purpose of this device is that you should connect your sensors, your buttons, your switches that are actually don't consume a lot of power. You should connect them to this device, this gateway, and then this works as a hub. But also it has a few features like alarm, for example. So I have a water flood sensor here, and the alarm should work if I put it into the water here. Okay, I put it, and we should hear the alarm, right? Hope so. Hope it works.
Wipe my shiny metal ass. Wipe my shiny metal ass.
Okay. So if you want to connect this button, there is a specific protocol called ZigBee, which is pretty low level. This is a low energy protocol. And this protocol allows you to use just very small battery, just the same as you use in your motherboard if you have a PC, for example. And this device or any other sensor could work up to 1 year without changing the battery, which is pretty cool. And Xiaomi actually has a lot of other devices. They have vacuum cleaners, they have air purifiers that work from Wi-Fi, but their ecosystem is growing a lot. So I won't show you everything, unfortunately. This is pretty hard to bring this big air purifier to the conference, right? Okay, is it working? I should have turned it off, maybe. Yeah, I forgot to turn off my demo. Okay, just need to launch it again to stop it because they won't. Okay, and kill the app. Okay, let's get back. And also we want to know about the official features because, well, if you want to program your devices, you want to know what the actual vendor provides you, and the vendor provides you the official MiHome app. I've shown you the lamp, how you can swipe before, but this is the main screen, and fortunately, it's in Chinese most of the parts, so they're like Zin Zan Zhao, the temperature. I don't know. Well, I started to learn Chinese, but well, not a good progress for now. Okay, so you can see all the devices that are connected. You can check the log if somebody entered your to your room or your home, for example. You can put the door sensor where it is, somewhere there. Okay, or you can have a log for the button, so you can see when you actually clicked or when you double click on the button. Pretty useful information. See the temperature in the room where your temperature sensor is located. See the chart, which is also not very good localized. Well, there should be the day, but okay, I think the Chinese guys didn't care about English after all. So the most important part, if you want to program your smart home, okay, it wouldn't be smart if you couldn't have some programming features, right? Is the Jingzhao, sorry, forgot Chinese. When you have a door sensor, you can add scenarios. So if you have a door sensor, you can connect it to some other device, and on the screen we have two scenarios. One scenario is when you open the door, play the radio. It's online radio. I don't have internet on my Wi-Fi router here, fortunately, but it's Chinese radio, not very interesting. And when you close the door, just stop the radio. That's pretty simple, and you can't write advanced scenarios, unfortunately. So that's where MiHome comes in. And well, I've shown you the renderer, right? And I wanted to, okay, so this is not React hardware because some guy invented React hardware. I don't want to make pull request. I want to make my own NPM library, right? Who doesn't want to put his library on NPM? So I thought about the name, and well, in Russian, dom means home. So I thought about naming it React Dom, but well, there is some small company called Facebook, I think, right? That already owns this package. So sorry, Facebook. I call it React Smart Dom. The code is already on GitHub, so you can observe it. If you buy a lamp, you can even run the project. If you don't have a lamp, sorry, guys. And the NPM library. So I've already reserved this name, so React Smart Dom, welcome. And now I will show you a few more demos with the sensors. Okay, so this was pretty simple. And the next demo will be the Disco app. Hope it works. Yeah. At least it should. Yeah. So if you are used to React, it should be similar with that to actually what you've used before. And yeah, I import. It's not called React Magic anymore. It's React Smart Dom. Yeah. This was the first version. So the Disco app has the state. It has the color, the initial state, the aquamarine color. Remember, we can use any color. The library just converted to RGB. And in component did mount, we actually just call the set interval. And inside the set interval, we have this set lamp color. And once in 800 milliseconds, we just call set state. We call set state. We set the color. We just select the random color from the list here: aquamarine, ivory, coral, lime, navy. Maybe this was a bad idea because I don't remember how half of these look like. But on the render method, you can actually use your parameters from the state. Enough. It's pretty simple. So when we return a fragment, so now with React, I think 16.3, you have fragments, and you render your lamps, and this is it. So we just one lamp is turned off when the other is working. The brightness is 30%, so you can see them because they're pretty powerful, and yeah, just changing the color, taking the color from the state. That's the whole app. And yeah, of course, we should render our Disco app with the Magic, Smart Dom renderer. Pretty simple. So, well, controlling the lamps is one thing, even with the button. Okay, we add the button, but here we add the gateway. But instead of just adding the gateway, because the button is like a child component of the gateway, we don't have the gateway here. I actually created a few components like button for the sensors, etc. Okay, maybe it should let's turn it off. And for the button, we can have different callbacks like on click or double click. And there we have those lamps, like in the previous one. The two lamps, they're actually there. Okay, so let's run this example, and I just in the previous one, demo 5. You should be able to see the request that it should send. Okay. Okay. Initial state isn't always good. So here on click, we just set, if the color is red, we set it to blue. And if it's not red, if it's blue or something different, we set it to red. So I click on the button. As you can see it should turn into red. Okay. Now, thank you. And okay. Yeah, Xiaomi smart home doesn't always work good, but let's check double click. Yeah, double click works. One click, red, blue. Okay, maybe it makes sense to use double click before clicking, right? That's it. That's quite well. We have 60 lines of code, and you can control hardware. For now, you can control Xiaomi, but in the future, if it makes sense, I will add a few other layers or other components that you can use. Or send pull requests, guys, if you're interested. And the last demo is more complicated because it contains a smart socket, which is also connected to the controller here. Well, you plug it inside the electricity grid here, and you plug something. Here I have a fan for the demo, and well, I have a door sensor. It's not actually a door, or you can think of it as a window, right? And what we'll do, well, yeah, I call this bedroom app. I don't know why, but let's say it's a bedroom. And in the state, we just have one parameter is on. Okay, it will be for the socket. We check if it's on or off. And we have the contact sensor, this one, right? When I'll open this, it should work, hopefully. Okay, it's Xiaomi, so it might not work. And let's launch it. Okay, sorry, I forgot about the methods. What we have, when you open the door, we just set state is on to true, is socket on true, or when you close the door, it's set to false. And the socket here should take the parameter from the state. So basically, when I open this door, the fan should start working, and when I close it, it should stop working. The socket should stop. Okay, let's see if it's working. I'm not sure. Maybe something is bad there. But yeah, it is. But when I open the door, when I close it, it should stop working. I hope it works. Yep. Here it is. It actually works. Wow. Okay. So, oh, I forgot about important this thing. Always forget about the dev tools. And in the dev tools, you can actually see the state, right? You can see the contact sensor, it doesn't have state. Okay, the power socket has state. It's on and off. So using dev tools, I can actually control this thing, I hope. Yep. And turn it on. Turn it off. Just like this. Okay, so I've had some references if you're interested. I just send you the presentation, maybe. And so thank you. Do you have any questions?
Yeah, raise your hand for the questions. By the way, thank you. That was mind-blowing. Really great.
What state management library you advise for this application? And what library for side effects? Maybe Rix?
Wow, this is, I wasn't prepared for this question actually. Well, I would say the same that you use for React DOM.
More questions? No questions? Uh-huh.
Can you tell about prices of this, all of these things?
Okay, so the light bulb that is blue now, I think it costs around $20, but if I bought it on Gearbest, if you get on a discount, for example, it could be cheaper. The controller, well, if you buy a pack, it could be $60 for the controller, a button, and a few door sensors. And I also have temperature sensor. It's around $12, I think. So that's it. So the smart home could cost like $100. That's it.
More questions? Yeah.
Thanks for your presentation and awesome inspiration. As I understand, you actually to work it, you need a PC or anything that can run Node.js scripts?
Yes, right. So I run it on the Mac, but I advise you to have a Raspberry Pi if you want to set it for production. I wouldn't set it into production myself, actually, but yeah, if you would do that, you would need a Raspberry Pi.
Other questions? Yeah.
Thanks for your talk and demos. They're great. I wonder, can you show some small details about how renderer is implemented, or at least device component? Just some code, maybe.
Yeah, so I think, yeah, I tried to make it quite simple because not to put a lot of information. Actually,
I guess just the idea how the renderer gets the updates, so it sends it to device.
The MiIO library has handlers. So inside the device component, the renderer just subscribes to it sends the callback. Okay, I want to have on press, right? It sends it to the MiIO library, and MiIO library actually has a handler. That's it. You call when MiIO finds out that there has been an event, it calls the callback, and then it propagates back to React. That's it.
Okay, thanks.
And as I got it, it is open sourced, so you can just go and look for it. Yeah, am I right?
There is a lot of room for improvement because I published the package, I think yesterday at night, so you can go and check it. But yeah, the code could be improved.
By the way, I got an idea. We have a Goodness Squad tomorrow. Maybe you want to participate, and maybe some of you want to contribute to this project and maybe add some more devices. Is it possible?
Yeah, maybe. Well, I just need to think about this. Nice idea.
Okay.
Need to think about the tasks. No, not sure what to do next.
More questions? Do you have? Okay, then thank you. Thank you once more. Yeah.
Thank you.